Assalamu alaikum. Welcome to lecture number 26 of Software Design and Architecture. I am your course instructor Fahad Anwar. So, students, before I start my today's lecture discussion, I would like to give you a little bit recap about our last lecture. So, students, if you remember what we discussed in our last lecture, we discussed a different categories of architectural pattern where we see what is a component based architecture, and then we see how a component can be made of a source code, executable code, and other files as well. And then we see, with the help of some diagrams as well, how a component interface actually look like, where we see how a component contains require interface and provide interface. And then we also see a real world example how a data model and how a model of a data collector component actually look likes, and what are the required interfaces and provide interfaces also we discussed in previous example, in previous lecture with the help of example as well. And then we also discussed a basic element of a component model, in which we see how a component contains interface, usage information, and deployment and use as well. And then we see a possible applicable domain areas where we can utilize this component based architecture. And then we discussed benefits and limitations of component based development. And then we see some crunch component technologies which are currently being utilized by the industry as well. Students, this is a little bit recap about our last lecture. So students, before I formally start my today's lecture discussion, so till here our different categories of architectural patterns or styles comes to an end, except event based architecture. And I left this event based architecture, students, for your self study. It's not your course part. So students, this event based architecture is for your self study. I will ask some questions in from you in some assignment or some quizzes as well. So students, so till here over different categories of architectural patterns or styles comes to an end, and we comprehensively look into details of all of these architectural patterns or styles which are currently being utilized by the industry. We also discussed all of these architectural patterns with the help of some real world example. We discussed their architecture limitations, benefits, and possible domain areas where all of these architectural styles can be utilized. So students, still here our architectural style categories or patterns comes to an end. So students, let's formally start our today's lecture number 26 discussion. So students, now the objective of our today's lecture discussion is documenting software architecture from practitioner community perspective. Now from in this lecture and in coming lecture, we will see how we can document our software architecture. So let's start how we can document our software architecture in different perspective as well. So students, before I start the discussion about how a document can be how a software architecture can be documented. So basically, software architecture document provides a comprehensive architectural view of the system using a number of different architectural views to depict different aspects of the system. So basically, our purpose of software architecture document is to provide a comprehensive view of the architecture of the software system. So this software architecture system is actually serves as this document of software architecture is actually serves as a communication between the software architect and other project team members. What are the other project team members, students? Other project team members can be like end users, customers, project managers, system engineers, developers, architect. All of these are other stakeholders or other project managers. So different software architecture will have different perspectives from different stakeholders. So typically a software architecture document actually contains from different views, their structures, rational mean the different constraints, context, problem description, which actually comes from the real world environment, different quality attributes which refers to non-functional requirement of any software system, and the principles and key guidelines, which actually we have been discussed in our previous lecture. Different key guidelines and principles for software architecture and design. All of these elements are actually being documented in this software architecture document, and in other words, you can see that a software architecture document must contain the information about all these elements, like problem description, which actually comes from the environment, the context in which the context is basically the environment in which the real world problem is existing, and the rationale means the constraints of the real world problem, and their views can be like different stakeholders can have different views as well. Their structures, different quality attributes, which refers to non-functional requirements, and key principles and guidelines of any architecture and design. All of these elements are all of these details of these elements are actually being addressed in this software architecture document. And in other words, we can also generalize this software architecture document term is that software architecture document actually contains the necessary information from all of these mentioned elements. So here is a uh, comprehensive generic view how actually a software architecture document looks like, or how what kind of elements actually contained in this software architecture document. And we can act students we can document our software architecture basically in two broader categories, which actually divided into two groups: the researcher community and the practical oriented industry practices or industry practitioner community. So the researcher actually thinks about the software architecture in a different way, which is actually more toward a theoretical approach, while industry people approaches toward this software architecture document in a more practical way, like by providing a UML based diagrams as well, which we already have been discussed in more detail in our previous lecture. So one of the main differences between these two communities, a researcher community and the real world industry practitioners approach, is taken to describe software architecture. So in the researcher community, actually researchers are more prone towards the architecture description language. So the architecture description language is another type of language which is actually utilized to document software architecture. It actually represents more formal notations for describing architecture in terms of different coarse grained components and connectors. And these ADLs are architecture description language are usually domain specific language. We did not study this architecture description language until our lecture number 26, and this architecture description language is not the your course part, but I would like to give you a little bit discussion about what is actually this architecture description language. Students, this architecture description language is a modeling notation to support architecture based development. It is actually used to define and model system architecture prior to detailed design and implementation. So this architecture description language can be used to specify an architecture. So UML is also another one type of architecture description language. So there are many architecture description language available, like UML is one kind of general purpose architecture description language. There is an SADL which is actually developed by SRI, Acme, which is actually introduced by CMU, which is an interchange format. Another type of ADL is Rapid, which is actually developed by Stanford University, and other one is like Ride, which is also developed by CMU, and other type of ADL is Draw-in, which is actually developed by Imperial College London. So students, these are the different types of architecture language which I listed out here. So you don't need to go through all of this architectural description language. So basically you can summarize about the architecture description language is that the architecture description language is actually is used to specify an architecture, or in other words, it actually provides a formal notations to describe an architecture. and researcher community is more prone toward this architecture description language, while the industry practitioners community is actually advocate using a general purpose language, which we call a UML, stands for unified modeling language. So this unified modeling language has becomes a tradition or fact or de facto standard for documenting a software architecture. So basically there are two standards, de facto and de jure. De facto means according to by tradition or by facts, and de jure mean according to law or regulations, while this UML basically has become a de facto standard for documenting a software architecture in industry practitioners, not in the researchers community. While in the researchers community they are more prone towards the ADLs, architecture description languages, while the industry practitioners are more focusing towards the UML, which is a general purpose documenting software architecture's de facto standard. We also have been discussed this unified model language in very detail in our lecture number 5, 6 and 7, if you remember, where we see different behavioral diagram, UML diagram and structural UML diagram. I don't need to recall the unified model language. We already have been discussed this UML based documenting software architecture in very detail with the help of some real world example, which we took the banking case study, and I provide you all of the behavioral diagrams and structural diagrams of a real world banking example. So students, this we have been documenting of software architecture through UML also have been covered in lecture number 5, 6 and 7. So my main purpose is just to tell about the there are two standards of documenting software architecture. One is in the researcher community and the other one is in the industry practitioners. The researchers community is actually more prone towards the architecture description language, which is an acronym for ADL, while industry practitioners are more prone towards the UML, which is basically a general purpose language. So what is the current tendency of documenting a software architecture? So as I discussed earlier, UML actually becomes a standard de facto for documenting the software architecture, while the architecture description languages on the other hand provides us the solid support for formal type of verifications and corrections, but it considerably more difficult to use than UML because unified modeling language are more easy to utilize because it is are more near to human understandings in terms of structural diagrams and behavioral diagrams, while architectural description languages are more difficult to utilize, which can only be utilized by a specific industry practitioners community, not by the general audience. General audience can utilize this UML based notations as well. So students, UML 2.0 also includes some extensions from ADL word. So you can also say that UML 2.0, which is the latest version of unified module language, also include some roots or some you can say that some roots or some extensions from architecture description language word. So we can say that UML is basically a industry practitioners community approach, and ADL is researchers community approach. So ADL is most more difficult to document any software architecture because it requires a domain specific knowledge as well. While on the other hand, UML is a general purpose software documenting approach, and it is widely utilized by the industry practitioners because it is because it is more general purpose, and it is easy to utilize by industry people. So however, current practice for documenting software architecture is commonly informal, and in many cases it is actually based on line and boxes and arrow notations as well. So here are some of the major disadvantages of software architecture, like ambiguity in the description, and some lack for detecting inconsistencies are also existing, and there are some inability to establish traceability between design and code. This traceability between detailed design and code is most important, while the last major drawback of our documenting software architecture is architectural details incompleteness as well. So these are the general disadvantages of documenting any software architecture. So students, these are the, so basically from here our approaches are being started to state what are the current models are actually available to document any software architecture. So basically there are the so there are more than five approaches, but these five are the more general approaches towards documenting any software architecture. So students, now from here we will discuss all of these approaches one by one. So students, the number one approach is 4 plus 1 view model, which is actually basically a documenting verification technique developed in late 90s by Christian. And the next one approach is Sonus view, which actually is a software architecture documentation technique which is actually used in industrial applications. And the third one is rational unified process, which is also a RUP, is derived from 4 plus view approach as well. And the fourth one is IEEE 1471 standard, which is a recommendation for software architecture documentation. And the last one is basis approach. So these are the five different approaches towards software architecture documentation. We will discuss all of these approaches one by one. So Christian and Son's approaches are foundational and have influences on the other approaches as well. So let's start the discussion of all of these approaches towards documenting software architecture. So students, the number one approach is Creighton 4 plus 1 approach, or a 4 plus 1 view model. Students, if you remember, this 4 plus 1 view model we also have been discussed in our lecture number 18, if you remember. So in the so basically this is an architectural view model which provides a technique for provides a technique for to verify different documents. So basically this is a 4 plus 1 view model. So we can say that about this view model actually provides partial presentations of other architecture like users, analysts, designers, developers, integrators, and the system engineers. So software designers can organize the description of their architecture in different views. So these are four different views: conceptual or logical view, physical or operational view, process or behavioral view, deployment and physical view, and the fifth one is use case or scenario view. So software designers or architects can organize the description of the architecture decisions in different views. So this 4 plus 1 view model was originally introduced by Philip Creighton in 1995, which actually provide as a four essential view with one additional view which we called a fifth view, or a user interface view. Basically, this 4 plus 1 view is an architecture verification technique for studying and documenting any software architecture design. So students, if you look into this diagram, this is 4 plus 1 view architecture verification technique. So you can see in this diagram, uh, this architecture is based on five views perspective of the application, telling us what diagram can be used to document each of those views. So students, if you look into the logical or structural view, actually this logical or structural view concerns itself with the functionality that is provided by the system and how the code is designed to provide such functionality, and what perspective is actually included in this logical and structural view. The analyst perspective and designer's perspectives are the two perspectives which are actually being addressed in this logical and structural view. And what in which stage we utilize this view is the requirement analysis, and we focus on the object oriented decomposition in this view. And this view is actually provides the functional perspective or the functionality of the system, and what kind of diagrams or architecture or artifacts can be utilized to in this view. Class diagram, object diagram, composite and structure diagram can be utilized in this artifact. Students, I already explained you this diagram in our lecture number 18, but now here we are discussing this 4 plus 1 view model in terms of documenting software architecture. So the second view is physical operational view. So in this physical no the second view is process behavioral view. If you look into the second process behavioral view, it actually focus on the runtime behavior of the system, how system processes communicate, concurrency, synchronization, performance, and so on. So if you look into process and behavior view, the system integrators are the perspective, and in which stage we discuss this view. We discuss this view in the design phase, and our main focus of this view is process or a function decomposition to achieve some non-functional requirements like performance, scalability, throughput, reliability, availability. All of these are different non-functional requirements which are actually being addressed in the design stage. So what kind of artifacts or architectural diagrams can be used to document these views, like sequence diagrams, communication diagrams, activity diagrams, state machine diagrams, and so on. All of these are different architectural diagrams can be used to model this process and behavior view as well. And now the next one is physical or the next one is process behavior view. So this process behavior the next one is implementation and developer view. It This implementation and developer view actually portrays a static organization of the code, component, modules, and packages as well. So if we look into the perspective of physical operational view, developers, project managers, all the stakeholders of this view, and it also this view is also addressed in the design stage, and our main focus in this view is subsystems decomposition. So our primary concern in this view is software management as well, and what kind of architectural diagrams or artifacts can be made for this view are the component diagram and the packages diagram as well. So and the last view is deployment or physical view. So this view actually illustrate the physical organization of the application is about what code runs in the what hardware. So in this physical view, it's about what code actually runs in what hardware. And the fifth view is actually obviously so the deployment physical view can also be architecture or artifact in the deployment diagram or a network topology diagram, which is not a type of UML diagram, but it is also some kind of informal or semi-formal type of architectural diagram can be utilized to model this deployment or process view as well. And now the fifth view is a use case or a scenario view, which we also called a interface view, and end user are the main perspective or the stakeholder of this view as well. So what kind of stage we can utilize it, like putting it all together we can utilize it, like what kind of concerns involved, like understandability and usability of the system is the main concern of this fifth view, which we also call the interface view. And we more focus on the feature decomposition and what kind of artifacts or diagrams we can utilize to document this use case or scenario view are the use case diagram and the user stories. So what are the use case diagram are gives us a functional perspective of the system, where we have actors and use cases, and we tell us how an actor actually communicate with the system. And this use case diagram also have been discussed in very detail in lecture number 5, 6, and 7. So students, from here I conclude our talk about this 4 plus 1 view model, which is actually provides as a verification technique for documenting software architecture design. Is there are different views there are different views there are different views existing for any project. So each view is documented or converted into architectural diagram by using different UML based diagram. So conceptual level logical diagrams include class diagram, object diagrams, while physical operational level include component diagram, packages diagram, while process behavior includes the sequence diagram, community diagram, and so on, while deployment and physical view contains a deployment diagram, network topology. So from here we can say that about this architectural verification technique. This way of visualizing a software architecture is actually based on five views of application, which actually telling us what diagrams can be used to document each of those views. So the next one approach is the Sony's approach. It is a more it is ये Sony's approach जो है ये less utilized की जाती है, and you can say that it is not most common. So basically this approach is based on a survey carried out on number of industrial application, whereby you can say that the system software architecture were analyzed. It is actually based on surveys. So they found structure involved in the system which actually reviewed fell into four different categories. So there are the four different categories involved in this Sony's approach, which is actually another approach to documenting software architecture. Conceptual architecture, which actually represent architecture in terms of components, connectors. So this one is the highest level of this architecture. And the next is the module architecture, which actually contains the functional decomposition and layer structure. And the next one is execution architecture, which actually contains runtime elements like processes, communication protocols as well. And the last category of Sony's approach is code architecture, which actually map code files to file system structure. It is used basically for building and installing the system. So these are the four different categories of Sony's approach. So this Sony's approach relationship among views are identified like mirroring relationship, hybrid view, corresponding relationship. These are the three different Sony's relationship among views which are identified. Mirroring relationship is actually used when an element in one view appears in others, while hybrid view is utilized which actually involve two or more views in a single view. And this corresponding correspondence relationship involves explicitly or clearly describing association among elements of different views. So these are the three different relationship among views are identified in Sony's approaches. So student, till here our today's lecture discussion is ended. Now in next lecture we will discuss our remaining three approaches towards documenting software architecture. So students, till here our lecture is ended.